Hello Revolution Prep, my name is Dr. James Ash. I've been asked to do a short math demo video, so that's what this is. Hope you enjoy. Okay, so I'm assuming you're some sort of typical calculus student, and this is a typical calculus type problem. You're asked to find the area of the region enclosed by these two functions right here, and that word area is a giveaway that we're going to have to deal with a definite integral of some sort. And so since we're going to have a definite integral, we're definitely going to have 2 points to integrate on. It's always a good idea, well, the real issue we face with some of these problems is figuring out what the problem was, and so it's always a good idea to draw something and get a grasp of what's going on if you can. And so there's my line, that's a 2x right here, and here's my parabola. Okay. So we have a picture, it's easy to see what's going on. It wants the region enclosed by these two guys, and so it's asking us to find this right here. Okay. When we integrate from one point to another, of course we find the area under the curve from whatever point we integrate, say right here at A to B. We want to integrate that but get rid of this, right? So we want to subtract that. There's a formula associated with this type of problem. Here it is right here. Memorize it or don't, but it's you find this area, right, and then you subtract the area. So you find the area and then you subtract the area you don't want. In pictures it looks something like this, and so the bottom function gives me that stuff in pink, and then I subtract it. The subtraction right there just gets rid of it. Okay. Alright, so back over here, we basically have two steps to this problem. First we want to find the endpoints of which to do the definite integral on, and then we're going to integrate on those endpoints. All right, so let's go ahead and start step one. Okay, so let's find those endpoints. The two curves intersect here and here. All right, so we're going to look for 2 points where those two guys intersect. They intersect when those two guys are equal. That is, when this is equal to this, so we'll just set them equal and solve. Sorry, this looks a little rough. I'm still getting used to this tablet. So much what we do in calculus is just getting really good at algebra. I want to solve for x here. I have a quadratic, so I want to set this guy equal to 0. And I need to get rid of the 2x on that side. And so that leaves me with the 2x over here. And it's equal to 0 like we wanted. Now I'm going to factor it, take out an x. I'm left with a negative x over here. And so these two parts, these two intersection points are going to be, these two values that are going to be the intersection points are going to be x equals 0. That's for this. And for this part over here, I have x is equal to 2. Okay. And so that's going to give me those endpoints for the different integral that we're going to now have to compute. Okay. And so, oh, I lost my points. 2 and 0. All right. And so this is going to be 0, and this is going to be 2. And so now all we need to do is, well, plug in our function for f, plug in our function for g, and get going. And seems that, excuse me, seems we've got a bit of a typo there. Okay, but almost the same function. So now we need to integrate these two guys, and it goes from 0 to 2, right? 0 to 2. And we're going to plug in our top function. And then we're going to subtract our bottom function. Okay. I found a good practice to put these in parentheses. Doesn't really help all that much here because I have a single term, but you can see if you have multiple terms, and you might forget to distribute that negative appropriately, end up adding when you should be subtracting. So I'm going to combine these two terms right here, and we're going to be integrating this. Alright, so what do? We just use the power rule for this, and we add 1 to our exponents there, and divide. So I'm going to add 1, and I get x cubed, and I divide, and I add 1 to this guy, so 1 plus 1 is 2, and I divide, and now I can straighten out that integral and apply the fundamental theorem of calculus. Okay. And so we just plug in 2, and then we get a value, and we plug in 0, and we take the difference of them. That's going to give us the the value for this integral. So for the first part, I'm going to plug in 2 and plug in 2 right there. That gives me 8. 2 cubed is 8. And over here this guy cancels out, so that gives me 4. And this is nice. I plug in 0 to both these guys and I get 0 plus 0. And so that's gone. And we're left with negative 8/3 plus 4, which gives us 4/3. Alright. There we go. Once we get past the what the problem is asking us to do, figure out what needs to be enclosed and go through the various steps, it's actually pretty simple calculus involved. Students love their calculators, so let's go ahead and check this on our calculator. Plug in your functions, graph it maybe in just the window so you can see it, and we can find the definite integral on this guy. And so I hit the second button, and because it's blue, and right there calc because I want to calculate. And let's go down here where the little integral symbol is. Enter. Okay, good. So I want the lower limit. Now I'm going to find the top function first. And there I go. So I'm on it. You can see my little cursor is on it. I'm going to swoop down here. And it says lower limit. Okay. And I'm going to type in 0 because that's where it was. And then upper limit, I type in 2. And look, oh, draws a little picture and everything. And so I have 5.333, 5 1/3. Oops. So that's the top function, and then we're going to subtract the area in the bottom function. So I'm going to do the same thing. Okay, so, oops, I'm on this guy now. So again, I'm going to do 0, and then I'm going to do 2. Okay, well, it's drawing the area on there, but you can see it gives me 4. Okay, and well, that's 1 1/3, which is exactly what we have over here. So hooray, we checked it. It looks right, and now the student believes it because the calculator said so. What's interesting about doing this in a calculator, though, is you have to sort of do it as we thought of it conceptually, taking the area and then subtracting it. Although you save yourself a little work by combining those together into a single function and using this formula right here. Now I could integrate it separately on a to b and then integrated g separately from a to b and subtracted the difference, which is what our calculator did. Alright, so back to our multiple choice here, and look, oh yay, there it is right there. Okay. A couple of quick notes. Look, this guy's definitely out. It's area beneath the graph and the x-axis, excuse me, and so it's definitely not going to be in the negative. All right, and this guy looks a little big, right? You could probably compute it from that. And so your really only options were these 3 guys, and there it is. All right, I hope you enjoyed my video. I enjoyed making it. Hope to hear from you guys soon. All right, have a good one. Have a good Thanksgiving.